All right, let's go through the second part of section 5.1. In 5.1b, we're going to be doing some solving of equations that involve trig functions. Sometimes we'll be doing these as general solutions, and other times we'll be doing them on an interval. So let's get some of these blanks filled in here. The first type of solving we're going to be doing today is generally, or in other words, we're finding all solutions, I think is actually what it says in our directions to an equation. In order to do that, you need to have multiples of the period. For example, 2 pi. And we do that by actually saying plus 2n pi, which represents adding multiples of 2 pi, because we say n can be any integer. The other way that we're solving this is in an interval, usually from 0 to 2 pi, including 0 but not including 2 pi. This is the easier of the two because you only are giving specific answers, any answers between 0 and 2 pi, where the general solutions you got to do a little bit of thinking as to what the period is, how you could maybe simplify your answer. So we're going to start with the easier of the two, with the solving in an interval. The equation we have is right here that we're going to be solving. We have a sine of x in the denominator. So, one thing we got to be careful of is finding solutions that could be extraneous because they, for example, put 0 in the denominator. We know that sine of x cannot equal 0 because it's in the denominator. Therefore, x cannot equal 0 or pi, because that's where sine is 0. If you think about your quadrantal angles, we have 1 comma 0 here, negative 1 comma 0 there. So those are the two spots that sine is equal to 0. So we know that x cannot equal either 0 or pi. All right, let's start solving this equation here. We have the cosine of x cubed over sine of x. I'm going to subtract that cotangent of x over and get this equal to 0. I'm also going to rewrite it as cosine over sine. And then what I'm going to do is multiply both sides of this by sine of x just to get rid of these fractions. So what we're going to end up with then is cosine cubed minus cosine. And we can solve this by factoring, by pulling out a GCF. I'm going to pull out a cosine of x, and that would leave me with cosine squared minus 1. This equals 0, so we'll set both of those factors equal to 0. Add that 1 over right away. So cosine of x equals 0. That happens at pi over 2. I'm going to answer everything in radians because of what that says. If it would have said from 0 degrees to 360, we'd do degrees, but it says 0 to 2 pi, so we'll have everything in radians here. So cosine is 0 at pi over 2 and at 3 pi over 2. And then we have, take the square root here, so we get cosine, don't forget positive, negative, square root of 1 is 1. So this, the solution to this is where cosine is both 1 or negative 1. Or either 1 or negative 1. So really that could happen at either 0 or pi. Okay, except we just said in the beginning that x cannot equal 0 or pi. So these are extraneous. Okay, because of what we wrote up above. So our only solutions here are x equals pi over 2 and 3 pi over 2. So that's an example. Now, we won't always have extraneous solutions. In fact, I don't think in our homework or on the review we have coming up, I don't think there's very many extraneous solutions at all, but I just threw it in there just to remind you that it can happen. All right, another big piece of what we're doing here is factoring. So we're going to solve this equation by factoring. Notice now we're finding all the solutions to this. So I'm going to kind of change two pieces of this problem here. So you have 2 sine squared plus sine of x. I'm going to subtract that 1 over, get it equal to 0. Then we're going to factor this. I know to start off with, I at least can have a 2 sine of x and a sine of x in my binomials. 1 and 1 here. One of them is going to be negative, though. I need these products here. Oops. I need this product and this product to add up to 1 sine of x, that middle term right there. So I'm thinking if I put the plus here and the minus there, that is our factorization. I'm just going to do a real quick check here. That'd be 2 sine squared. Then we have positive 2 sine minus sine. That would give me the plus sign in the middle. And then the negative 1 times 1 gives me that negative 1. So this is the correct factorization. Now that we've factored, we can set both of these equal to 0. So we have sine of x equals 1/2. And sine of x is going to equal negative 1. So sine of x equaling 1/2. Now you got to be careful here. We want to find all of the solutions first between 0 and 2 pi, kind of like we did up here, kind of how we thought about this one right here. We want to find all the solutions between 0 and 2 pi that would make this equation true. So that value of 1/2 tells us that our reference angle is pi over 6 because it's a sine. So the sine of pi over 6 is 1/2. But we need to recognize that it's positive. So where is sine positive? Well, sine's positive in quadrants 1 and 2. So our answers here for x would be using pi over 6 as a reference angle in 1 or 2. Well, that would definitely be pi over 6, and that would be 5 pi over 6. Okay, so those are our solutions so far. I'm going to start just doing a sketch over here of what my solutions are. So we have right now pi over 6 and 5 pi over 6 as our solutions to that first factor. All right, and then the sine of x equaling negative 1. Let's change this color here. All right, so when I'm going to just do this one over again. All right, so where is sine equal to negative 1? Well, I'm just going to use my quadrantal over here, or my little sketch that I have over here. Sine is negative 1 right there, right? 0, negative 1. So that is our solution to this guy, 3 pi over 2. All right, but now if you look at our sketch over here, these are all the solutions in one trip around a unit circle. If this would have been on the interval, so if this were the type of question where it said solving the interval from 0 to 2 pi, then our solutions would simply be x equals pi over 6, 5 pi over 6. I always like to put them in order, and then 3 pi over 2. Okay, and we'd be done, and we'd be done. Okay, but this is saying find all the solutions. So what we know is pi over 6 is a solution, and so is all of its coterminal angles. So in other words, if I took another trip around and then another trip around, so any angle that's coterminal with pi over 6. Any angle that's coterminal with 5 pi over 6 would also be a solution. Any angle that's coterminal with 3 pi over 2 would also be a solution. Okay, so what we could do is just write each of these and say pi over 6, don't write this, just because I'm going to erase this in a second, but pi over 6 plus 2n pi, 5 pi over 6 plus 2n pi, and then 3 pi over 2 plus 2n pi, and just say each of those angles and all of their coterminal angles. That would cover all the solutions. However, what I want you to notice is, and sometimes this happens, you can simplify that statement. If you notice here, pi over 6 and 5 pi over 6, I can get from one to the next by simply adding 4 pi over 6, or 2 pi over 3. If I add 4 pi over 6, or 2 pi over 3 to the 5 pi over 6, it gets me down to this guy. And that would get me all the way back up here, too. In other words, I don't need to list all three of those angles. If I just start with pi over 6, I can add multiples of 2 pi over 3. So to represent the fact that it's multiples, we've put an n in there. You could have 2 pi over 3n. I just like putting the n up in the numerator. Either one is fine. But this then says add multiples of 2 pi over 3 to pi over 6, and you will cover all the solutions to this equation. So this is how we're going to represent our answer in the most simple form. All right, the last type of question that we're going to have here, unfortunately, I can't use my calculator here at home, so the one that's on the screen. You're just going to have to graph it on your own and kind of trust the sketch that I put up here in a second. We're going to be using a graph calculator in order to solve cosine of t equals 0.7. I'm going to do a kind of a sketch here as we go. Let's see here. We'll graph both sides of this as its own equation. So we're going to graph y equals the cosine of t, or cosine of x, and obviously that is going to be a cosine graph like that, positive cosine graph. This is asking us to find all the solutions to that equation. Just kind of taking this in here for a second. All right, and then the other graph that we are going to graph is y equals 0.7. Well, we know the maximum of y equals cosine of t is 1. I mean, without even putting this on a graphic calculator, we know that. And then, so our 0.7 is going to be about right there. That's y equals 0.7. So what we're looking for to start with are these solutions right here and right here, okay? And if we do that on a graph calculator, you're going to find out that the intersection of those two graphs are at 0.8 there and at negative 0.8 right there. Okay. You could also picture the unit circle here with this, that if we had a cosine value of 0.8, okay, that'd be going, that would give us this angle right here and this other angle from here to here. Okay, because this is in radians. That's where the 0.8 is, just to make sure that we understand that. So when I'm drawing this 0.8 here, that's not the cosine value. That's the radian angle, 0.8. So we know that x is going to equal 0.8, and then I'd also be short 0.8 here of going all the way around. So that would be 2 pi. This one would be 2 pi. Sorry about that. Actually, I'm describing this angle here. 2 pi minus 0.8, which would be 5.48. Okay, so those are the solutions in one trip around the unit circle. Okay, it's only positive because it's positive 0.7. It's only positive in the first and fourth quadrants. Cosine is only positive in the first and fourth quadrants, which is where we're getting those solutions from. All right, now that's asking us not, this should be on the interval from 0 to 2 pi. But it's asking us for all those general solutions. So what we're going to do, there's no way to simplify this answer like we did in the last problem. So what we're going to do is just say one solution is 0.8 and all of its coterminal angles. The other solution is 5.48 and all of its coterminal angles. Okay, and then that would be the general solution to this equation.